Alright, sorry for that interruption. We're going to have to redo that last problem. As you probably heard, somebody was yelling outside my door, and I figured you just didn't want to hear all that. But here we are. We are finding the exact value of sine of x over 2, of cosine x over 2, and of tangent x over 2. Okay, so, and sine x, they said, was negative 3/5. And we said that it was in quadrant 3. X was in quadrant 3. So, now note, one thing for you to note, what do all these have in common? Okay, what do all these have in common? Well, they have cosine x in common. Okay, so what we need to do is we need to find cosine x. Well, that's not going to be hard for us because we know sine squared plus cosine squared equals 1. And we were given sine squared is negative 3/5. So we can substitute that in. And because we're in quadrant 3, we know cosine is negative. So you can get your cosine x here very easily to be negative 4/5. Okay, we can find that very, very easily like that. Now, once you know cosine x, you will be able to solve this just like it's a piece of cake. So we would very easily be able to figure out what the sine of x over 2 is. And so that's the square root of 1 minus the cosine of x all over 2. Now we know cosine of x is 4/5, negative 4/5 I should say, all over 2. So that's going to be the square root of 9/10 is what that ends up giving us there. The square root of 9/10. And that would, you could write that as 3 over the square root of 10. Now, how do we get 9/10? By simplifying that top and dividing by 2. Okay, so keep that in mind. Don't let that confuse you. Now, just the same way, we could get cosine of x over 2. Okay, so now its formula is almost identical. The only difference is it's plus cosine x over 2. Substitute negative 4/5 in again. And you should get a negative 1 over the square root of 10 for that answer. I'm going to let you do that so that you can get some practice with it. Substitute it in just like we did in the last problem. Alright, what about tangent of x over 2? What about tangent of x over 2? Well, tangent of x over 2, you've got formulas involving cosine there on page 260 that you can use. You can use those formulas by all means. If you need to, go ahead and use them. Now, one thing I want to call a note to, this has got to be negative. I wrote the final answer as negative, but why does that square root have to be negative? Because we are in quadrant 3. Cosine is negative in quadrant 3. Alright, in quadrant 3, tangent is also negative. So if you do any square roots with tangent, you would have to use the negative. But I'm going to show you a little trick that they're not showing you, they don't show you in that formula page in the book. Sine of x over 2 over cosine of x over 2 is the same thing as tangent of x over 2. Now I know that should definitely make sense. Okay? So that's 3 over the square root of 10 times the square root of 10, negative square root of 10 over 1. I just multiplied by the reciprocal there. Okay, obviously. Multiplied by the reciprocal. So those two would cancel. So we just get negative 3 for our answer there. Okay, so not all the time will you have to use those formulas that you're given. You can use some common sense like we did there. But you could have used some of those formulas and very easily gotten the same thing, okay? So don't think that my way is the only way by any stretch. I'm just trying to show you the most efficient way. And last but not least, in section 4.4, you know as well as me that I can't let you get out of here without doing an identity. Alright, so cosine squared of x over 2 equals tangent x plus sine x over 2 tangent x. Now, I'm going to use the left-hand side because I see an identity there already because of the x over 2. So basically what this is plus or minus the square root of 1 plus cosine x over 2 squared. So basically what I did is I took this and I rewrote it as the cosine of x over 2 squared, which equals that. Now, cosine of x over 2 is plus or minus the square root of 1 plus cosine x over 2. So you can rewrite it like that very easily. Now, when we square a square root, it obviously cancels out the square root and cancels out our plus or minus signs. It's just going to make everything positive. So we're left with 1 plus cosine x over 2. Now, here's where the tricky part comes in. I chose to work this side not only because I had an identity, but number one, because it's the side that most people choose, and number two, because when people do choose this side, they tend to get confused right here. They tend to look at that and not know anywhere else to go. Well, here's what I would ask you. What are you trying to get on that right-hand side? Well, you're trying to get, notice we're trying to get tangent x on top and bottom. So I'm going to try something. Will you let me try something? Let's try something. I'm just going to manipulate it a little bit. Sometimes it's trial and error. I'm going to manipulate it, and I'm going to multiply the top and the bottom by tangent x. Well, look at what that does. That gives me tangent x plus cosine times tangent. Tangent, remember, is sine x over cosine x. So when I multiply that, the cosines cancel, and that just leaves me with sine. And then tangent times 2 is 2 tangent x. Well, look at there. I got what I needed. Sometimes it's looking at what you need and manipulating. It's not always going to be some awesome substitution that makes it easy. Sometimes it's going to be just a matter of doing some algebra and manipulating and trial and error to get these identities. Okay, so here's another method. If you notice these methods, I'm showing you different methods for solving these each time. I'm not just doing straight identities most of the time. So I'm trying to work in some of these methods so you see more of them and it gives you a better shot of getting them right, okay? So make sure that you are practicing that. So that verified our identity with the right-hand side. So make sure you're doing this homework. Practice, 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 because it will take a little while to do this one. So make sure that you're getting in there, getting it done kind of early. Have a great day.